Welcome, welcome, welcome. Here we go again, the triangle inequality. This is our next section that we're going to cover, and today you will use the triangle inequality to identify possible triangles and prove triangle relationships. Now, what I would ask is this, because I'm starting to notice some of y'all are doing something like this. Make sure you're copying down every slide, everything, not just copying down what I write. Don't be so lazy, get it all. Anyways, first thing, let's talk about what is the triangle theorem, inequality theorem. It states that the sum of two lengths, so I'm just worrying about this right here. The sum of two lengths of any two sides, or the sum of lengths of any two sides of a triangle must be greater than the length of the third side. So, basically it means if you add up two sides, they're going to add up to be greater than the third side, no matter what two sides you pick. Now, we're going to shorten that up a little bit, but we'll see. Let's look at an example. Is it a triangle? Let's play our favorite game. Is it a triangle? Oh, just kidding. Anyways, okay, so here's three sides. One is 8 inches, 15 inches, and 17 inches. The question is, could that make a triangle? Well, if you add up 8 and 15, that adds up to, it has to be greater than 17, and that adds up to 23. So at least that one would work. Then if you add up 8 and 17, it has to be greater than 15, which it would obviously because 17 is already greater and you're adding to it. And then if you did 15 and 17, it had to be greater than 8. Obviously, that would too. And so you can see there that, yes, this would be a triangle. Now, the real thing is, and this is a little bit, let's go a little bit more direct than what this theorem is saying. The real thing is that you would tell, if you basically add the two smaller sides, if the two smallest sides are greater than the third largest side, which I'm sure we'll see another inequality that we'll talk about that more, then it should be a triangle. Because obviously, the largest side being added to either of the two is going to be bigger than a small side. Anyways, let's look at another example. 6, 8, and 14. 6 plus 8 has to be greater than 14. 6 plus 8 is 14, which is not greater than 14. It's a lot of times me saying 14. So this one would not be possible to become a triangle. It has to add up to more than the third side. Plain and simple. Once you see that it's not working, then you move on to the next one. Let's do one more example. Okay, so I got interrupted there for a second, but I was about to say 15 yards, 16 yards, and 30 yards. So let's look at this. Look, if I add 15 plus 16, I get 31. Those are the two smallest sides, and they are bigger than the largest side. So this should be a triangle. If I check all the other ones, the other two, let's say 15 and 16. I'm sorry, 30 and 16. I'll get it right in a second. 15 and 30. 30 is already bigger than 16. So I know if I'm adding 15 to that, I'm going to get a number bigger than 16. Same thing if I switch those and say 16 plus 30. 30 again is bigger than 15. So if I add something to that, it's going to be bigger than 15. Duh. So yes, those two are kind of unnecessary, but they're part of the theorem. The point is, what I'm saying is if you just add the two smallest sides, and they are bigger than the largest or the longest side, then yes, it could be a triangle. All right. Whoops, went too far. Okay, so you can use the triangle theorem to find a range of sides if two sides are known. In other words, if you know two of the sides, then you can kind of find the largest and least numbers here. And what we're going to see is here, this was in the book, and they're like, oh, we got 3 and 5. Well, depending on how you draw the triangle, you could get a side that's 7, or you could get a side that's 3. The way to do that is this: if you add the two sides that are known, you get 8, and you know it needs to be less than that because it's got to. Remember, the two sides have to be greater than when you add them together. Also, you could subtract, and you would find out that then those are the numbers that they need to be bigger than. So rather than saying equal to, let's rearrange that and say x needs to be less than, notice how I'm writing that, less than whatever 3 plus 5 is. So if you know the two sides, x needs to be less than the two sides you're adding, but at the same time it should be greater than the two sides you're subtracting. So notice here that 7 is less than 8. 7 is less than 8, but 3 is greater than 2. Okay, so let's try this. Let's say I give you sides 3 and 7. I know that I need something less than and see something greater than. And I might make this part of my notes. X needs to be less than adding the two sides, a plus b. X needs to be greater than b minus a, subtracting the two sides. Now, when I say b minus a, I'm saying the bigger one minus the smaller one. Always the bigger one minus the smaller one. All right? So here I'm going to say 3 plus 7 is 10. 7 minus 3 is 4. So x needs to be less than 10 but greater than 4. So if I gave you all multiple choice and say, oh, 3 feet, 4 feet, 5 feet, 10 feet, which of these sides could possibly make a triangle with 3 and 7? 3 can't, because that would be lower than the 4. 10 can't, because that would be equal to, but it's got to be less than. 4 can't, because we have to be greater than 4. So the only one that works is 5. So 5 would have been the answer there, and that would represent the least, I guess the least amount, if you want to put it like that. Now, keep in mind that if you added another one, let's say like 9 could work because it's less than the 10, and that one would kind of represent the greatest amount. So we're basically creating ourselves a range that we're saying that any length lowest, between 4 and highest 10, anything between 4 and 10 would allow us to have a triangle. And this right here would also be a way of saying that this is the range of measurements that would allow us. That could also include decimals and stuff like that. All right. So just as a reminder, again, if you're wanting to find the range of sides and they give you two sides, if you add the two sides together, you get the greatest number it could possibly be, or the highest it can be, which means it has to actually be less than that. Notice this is not an equal to. And if you subtract the two numbers, you get the least. So if you want to write it as a range, it's the least, x is between, notice x is between the least and the greatest numbers, the larger and the smaller number, okay? Anyways, that will be it for today. Thank you so much for your time. Y'all take care. Hopefully y'all got everything, and I will see y'all next time. Thank you.